Hello, I'm John Patsavellas. Every year in the National Manufacturing Debate, we present a topic that is relevant to the debate subject. This year, together with our manufacturing master students, we have looked at the manufacturing data coming out of the fourth industrial revolution, and we looked at its green and energy issues. We have heard that the size of the prize of the digital transformation manufacturing is a big one. Certainly, through the Industrie 4, the fourth industrial revolution, we've heard from our German colleagues over in 2016 that the potential benefits to the cumulative value of digitalizing manufacturing could be up to 425 billion euros in Germany alone, with a big impact on productivity up to 30%. Similarly, in the Made Smarter review in 2017 for the UK, a similar number has been quoted as the size of the prize for digitalizing manufacturing, 455 billion, by adopting digital methods and innovation in manufacturing over the next decade. The big promise of the fourth industrial revolution is that by connecting machines and infrastructure with the control systems and the planning methods in factories, manufacturing can be transformed. Efficiencies can increase, flexibility can increase at the same time, as well as responsiveness, whilst we're driving down the usage of materials and energy. However, at every level during the fourth industrial revolution, we need data. Data is required at every step of the way. And it's a good thing because it enables to get manufacturing plants, processes, and enterprises to begin to see more of what is going on in their own environment, increasing their visibility, and then increasing the transparency, understanding of what exactly is happening in a way that has not been possible in the past, leading to predicting events, predicting demand, matching supply to demand, and being able to respond to disturbances, ultimately rising to the self-optimizing state of a manufacturing system where automated responses could be absolutely matched with the prevailing conditions in demand, in production, and in the state of manufacturing systems. Data is crucial for the fourth industrial revolution, and we know that the fourth industrial revolution is based on sensors who generate data. That data, sufficiently in big amounts, can lead to techniques such as artificial intelligence, reaching the higher levels of maturity eventually for predictability and autonomous responsiveness. However, this data, as it comes from sensors, these sensors are getting cheaper all the time. We have seen a decline in the unit price of micro electromechanical sensors, industrial Internet of Things sensors. They're becoming increasingly affordable, dropping to below 40 cents per sensor over the last couple of years. And crucially, we have reached a great milestone. Very recently, 1 trillion semiconductors per year. We have been able to produce that amount of semiconductors globally. These are the enablers of the fourth industrial revolution, which generate data. We know that the data produced already in the world is great, is huge. And through the digital transformation of manufacturing, using industrial Internet of Things sensors, this data is bound to grow. We see the connected devices are due to experience an exponential growth over the next few years. The purple part of these graphs show that IoT is going to grow in terms of connections. And the statistics with regards to the data creation are mind-blowing when we consider that 90% of all data created has been created in the last 2 years. We create something like 2.5 quintillion bytes of data every day, and that's 10 to the power of 18 bytes per day. Each one of us generates 1.7 megabytes of data per second, and the statistics of how much data is created daily, every single minute, in fact, really large numbers. So this data, however, isn't free. Data should be equated to energy because there is energy required to generate data, and we've calculated that to be up to 1.96 kilowatt hours per gigabyte. We need data to be transmitted, therefore we need energy to transmit data. We need energy to store data, and we need energy to retransmit data from the storage location back to the end users and machines over its useful life. And if we look at the data as an asset and we take a 10-year life, we can estimate that over that period of time, a gigabyte of data would require 2.66 kilowatt hours. If we use the current profile of energy production in the world, which still remains in its majority a hydrocarbon derived electrical energy source, we can estimate that 1 kilowatt hour of electrical energy emits 544, a little over half a kilogram of carbon dioxide. Therefore, a gigabyte of data over its 10-year life will probably emit something like 1.45 kilograms of CO2. And that's just 1 gigabyte of industrial data. Now, it's very difficult to comprehend the enormity of what the digital transformation in manufacturing will bring when it comes to data. However, if we were to look at the adoption of industrial robots coming up the next few years, and we calculate the data required for these robots to generate and use for the wayfinding, for autonomous robots, for the positional accuracy, and for the autonomous element of the functionality increasingly in manufacturing environments, then we have calculated the possible amounts of carbon emissions that just the cameras and wayfinding sensors these robots will require. And we have then calculated the corresponding carbon dioxide emissions, which at the most optimistic level over a 10-year period is around about 200 million tons of CO2. Of course, the pessimistic scenario is more than double that. So we have a suggestion. We believe that green data is what's needed for a green fourth industrial revolution. And we propose some criteria for considering data to be green. In manufacturing, we like talking about lean ways of doing things, value creation. So, as a first criterion, we would like to see that the absolute minimum amount of data is generated and compressed in order to transmit it. We also think that data should come from energy that is clean and renewable, and that wherever the data is stored should be a place that utilizes the most efficient hardware. We applaud some of the big data cloud companies that have already adopted some of these principles, and we would like to see all of them adopt a similar approach. Ultimately, we think there is an opportunity here for the world to rise to the fact that there needs to be a green data assurance and certification scheme, a supply chain of providence for green data. This is how the fourth industrial revolution can be a green one. This is how data can be seen as an aid towards the objective of net zero and not an obstacle. Thank you.